kind of one that kind of goes over heavily into geo. Just kind of checking, there's Lucas, checking your work. Simplify, I wrote down what perfect square I used to simplify there. So you can kind of see how I got to my final answer. And these coefficients that are out front, like the 4 ends up multiplying by the 5 that I take out. Well, you can't see, that's weird. You can't see my pen, it's like stuck. Let me exit out of that. I'll reshare. That was weird. All right, let's try this out. Okay, so for example, on 3, 125, factoring that is 25 and 5. When I take the square root of 25, that's going to get multiplied by that coefficient that's already out front. Okay. So now I'd like to go over the bottom section of this. So yesterday in class, so if you were in class, you have the notes. If you weren't in class, hopefully you've watched the videos. We talked about the Pythagorean theorem. So I can either use the Pythagorean theorem here to solve, or I can use triples. And so a few triples we want to be on the lookout for is really, let's just focus on the 3, 4, 5. Here was our list of triples, right? So here's one version of the list, and here's multiples of those triples. And I said, let's focus on 3, 4, 5 and finding 5, 12, 13. Now, what's important with this is that these have to be the hypotenuse when I'm looking for these triples. So absolutely, for any of these, you can use the Pythagorean theorem and solve for the missing value. But like on this first one, I see that this is 3 times 2, and this is 5 times 2. So there's my 3, 5. This side would have to be 4 times 2. It's just a multiple of that first triple. So I know that x is 8 using a triple. Okay, now do I have to know the triples? No, I could have written this and solved. This is just faster to be able to look at it and go, oh, well, x is 8 there, because that's what my triple is. On the second one, I also have a triple here. This is 3 times 4, and this is, oh no, I lie. No, it'll be fine. And this is 3 times 5, so I have 4, 5. This would be 3 times 3, 3, 4, 5, multiplying them all by the same factor. So x should be 9 here. And again, if you did the Pythagorean theorem, you still get x equals 9, okay? Just depends. On 9, this was also a triple. This was 12. There's no multiple here, it's just a 5, 12, 13. And then I get here, and so this is not a triple. So I have 4, don't have 5 here. This is not any multiple of a triple. So I can't just say what the missing side is. I have to use my theorem. And then remember, hypotenuse, always the side across from my right angle, right? So when I set up that equation, I have to have my legs squared equaled to my hypotenuse squared. Oh, yeah, I am recording that. And then I solve from there. So 4 squared, 16, 8 squared, 64. And it's just like solving an equation. Subtract 16. X squared equals, not in a place to do mental math today, 48. Then how do, so then from here where I have x squared, inverse of x squared is taking the square root of both sides, leaves me with just x equals the square root of 48. Now, we wouldn't leave a radical that can be simplified. What perfect square number goes into 48? $16, good. Sorry, I was seeing, I'm getting a lot of alerts that people are leaving, but I think it's algebra kids leaving. So 48, yes, if you're an algebra student, you can just leave once you've submitted it. And also, if you're an algebra student, if you have your volume on right now, you should be finishing up like right about now and heading to your next class and submitting. So 48 is 16 times what? 16 times 3. So I factor that 48. Here's my perfect square, gives me 4 rad 3. There's my missing side. Okay. 11, not a triple. So one triple I look for is 12, 13, 5, or I should go this way, 12, 13, 5. That's not going to work. And this is 3 times 4 or 4 times 3, but this is not 5 times something. And because this is the hypotenuse, this would have to be 5 times something for that to be my other triple that I'm looking for. So instead, I'll use my Pythagorean theorem. And again, this has to be my C value, right? That's my hypotenuse. So it would be x squared plus 12 squared plus 14 squared. 196. Gives me x squared equals 52. Take the square root. X equals the square root of 52. Square root of 52 can be simplified. What perfect square number goes into 52? 4. 52 is 4 times 13. Simplifies down to 2 rad 13. Last one on our homework, again, not a triple here. If it's 5, then this would have to be 12, 13. It's 5, 10. So instead, this time my hypotenuse is missing, which is a little easier because I don't have to do like the solving piece. I'm just going to have 5 squared plus 10 squared equals x squared. My hypotenuse is the part missing. Or 25 plus 100 equals x squared. 125 equals x squared. X equals the square root of 125. And what perfect square goes into 125? It is 25 times 5, or x simplifies down to 5 rad 5. Okay, so that was just last night's homework, just a little refresher of the Pythagorean theorem. Okay, so if you can find your notes, we're going to take really quick notes today, or quick-ish notes, I should say, and then I will let you go, and you'll have a little bit of homework before class tomorrow. So you want to, oh, it says notes number 1 again. It should say notes number 2, but it says notes number 1 again. It's the first time I've done that. And it says converse to the Pythagorean theorem. If you can find that. Okay, so I'm going to write the Pythagorean theorem in an if-then statement in this first box. So my Pythagorean theorem states that if, going back to like, what was this, unit 2 that we did if-then statements. If a triangle is a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the legs. So I'll give you a minute to write that down. So going back to when we wrote if-then statements, we said that the hypothesis comes after if. Okay, so here would be my hypothesis. A triangle is a right triangle. And the conclusion comes after then. We have, if this is true, then the square of the hypotenuse is equal to the sum of the squares of the legs. This is my conclusion. When we were in this unit where we were writing these if-then statements, we looked at the converse and then decided if the converse was true or false. When we did the converse, all we did was we flipped the conclusion and hypothesis around. So the converse to the Pythagorean theorem, the way it's written, would say if the square of the hypotenuse is equal to the sum of the squares of the legs, long statement. If that's true, then flipping this around, the triangle is a right triangle. Triangle is a right triangle. We'll give you a second to write that. So what this means, if we don't have a visual, or if we're not told a triangle is a right triangle, we can conclude it's a right triangle if the converse of the Pythagorean theorem is true. Or let me draw a little diagram here. So I'm going to call this A, B, C. Here's my right triangle. And the side across from A, I'm going to call little a. Side across from B, I'm going to call little b. Side across from C, I'm going to call little c. And we're going to say that if I have a triangle, and I know that a squared plus b squared equals c squared, and we're going to see we're not actually even going to be given the visual. Yeah, algebra students, when you're done, you can leave. Then triangle ABC is a right triangle. But I can also determine if a triangle is an acute or an obtuse triangle. So remember, acute means all of my angles are less than 90. So maybe it looks something like, well, I didn't do a very good job making that one not look 90, but that's okay. A, B, C, little a, little b, little c. And what's true, so if you submitted your work algebra in your algebra, you can head out. What's true when it's acute is that two sides, the two smaller sides of the triangle added together, will be greater than the third side squared. And this has to just be the largest side. We no longer have a hypotenuse if it's acute. We're just going to have three sides. So going two smaller sides squared, is that greater than my largest side squared? If that's true, then we can determine that triangle ABC is acute. Okay, so now we can look at three numbers and know that if it's a right triangle, or we can look at three numbers and know it's an acute triangle. Alexa, you're all set to do that. If you submitted, you can head out. Thanks. And we can also tell, given three numbers, if it's an obtuse triangle. So again, if I had a triangle, ABC, ABC, and if I look at the three sides and a squared plus b squared is less than c squared, then triangle ABC is obtuse. And again, this is the largest side or longest side. And these are called our Pythagorean inequalities. Okay, so the converse to the Pythagorean theorem is really just this first one. If I know this, then I know that. From that, we build these inequalities that tell us that if I know this, then I know it's acute. If I know this, then I know it's obtuse. And I'll scan these in later. So if you missed any of this page, make sure you go back and get it because we have some quizzes and this is a really good test. Also this unit when we take it in a couple weeks. Okay, so flip this page. At the top, it says, using the Pythagorean inequalities, classify the triangles. So here they are again. Now, I don't know what helps you, but for me, it helps me to know kind of, I think about these as opposites. Like obtuse is greater than 90, but for the inequality, it's less than, that would be true. Acute is less than 90, but the inequality is greater than. So for me, that just helps, like that idea of that it's opposite. So given three sides of a triangle, again, we're not given the visual, we're gonna decide if it's an obtuse, acute, or right. And so the way that I do this work, first of all, I identified what C is going to be. So C is always going to be the largest side. And when we get to radicals, we have to talk about how to figure out if it's the longest side or not, because they're not always in order, smallest to largest. So what I do is I go A squared plus B squared, how does it? I'm just kind of leaving a blank compared to C squared. A squared plus B squared, how does it compare to C squared? 4 squared, so I have 16 plus 16. How does it compare to 6 squared is 36? Then I add those together. 32 compared to 36. And I would say, well, 32 is less than 36. Okay, well, if A and B are less than C, or A squared, B squared is less than C squared, less than obtuse. So again, it's kind of opposite of what you're thinking of. When you think of obtuse, you think greater than 90. Less than, for our Pythagorean inequalities, means this triangle must be an obtuse triangle. Okay. I'm going to skip to another one that doesn't have a radical. So on D, again, first thing I do is identify this is my largest side. And I'm going to say A squared plus B squared, how does it compare to C squared? Or 36 plus 64 compared to 100, which gives me 100. And 100 compared to 100, it's equal. So what type of triangle do I have here? I have a right triangle. Okay, so I don't fill anything in between. What some students do is they make the mistake of always putting equal. Yeah, that's fine if you added the text as an attachment, I guess. I don't know if it'll let you submit, will it let you submit it? As long as it will let you submit it, it's fine. Okay, some students put equal the whole way through and then they get confused. Just leave a gap and then decide at the end which, if it's less than, greater than, or equal to. So now let's look at one with some radicals. So I'll look at these last two and then I'll kind of give you a chance to try them and I'll fill in answers for the rest. So when we have rads, there's kind of two things that could happen. If they're all inside a square root, well, then I know the largest value inside the square root is the largest number. The square root of 14 is going to be greater than the square root of 7. So I know that this is C. And so when that's the case, I can just go, okay, well, 7 squared, rad 7 squared, was rad 7 squared. How does that compare to the square root of 14 squared? Now what happens when we square a rad is it's their inverse operation. So they're just undoing each other. If I have the square root of 7 squared, they're undoing each other. It's just leaving me with 7. Same idea here, just leaving me with 7, just leaving me with 14. So it really just eliminates the rad and leaves you with the radicand, the number that's inside the radical. 7 plus 7 is 14. So again, I get that my two sides are equal to each other. And if they're equal to each other, then we know that that is a right triangle. Where it becomes challenging is when I have two integers and then a value that has a radical listed in it. And I have to kind of think about, is this number going to be greater than 8, basically? Is 8 the largest number, or is this number greater than 8? And so what we need to think about is what the square root of 3 would approximately be. So if we don't have a calculator, we have to think about what would this be. And so I would know that the square root of 3 is going to be 1 point something. The way that I know that is that the square root of 3 is between the square root of 1 and the square root of 4. Square root of 1 is 1, and the square root of 4 is 2. So the square root of 3 is somewhere in there, 1 point something. Because I know that the square root of 3 essentially is less than 2, I know that 8 is my largest value, because 4 times 2 is 8, and this is less than 2. Okay, so you do have to do kind of some mental kind of thinking here in terms of where is this in terms of the order of things. And there's some up above where it's not actually listed smallest to largest. So you have to just kind of be really careful and think about that radical before you start plugging things in. So now I have a squared plus, and we also need to talk about what happens here. How does that compare to my largest side squared? So I have 4 squared, which is 16. Now, going back to some radical review here. When I have 4 rad 3 squared, what I need to do there is I need to square the 4 and I need to square the rad 3. So squaring the 4 gives me 16. Squaring the rad 3 leaves me with just 3. Radical stuff's really tricky. How does that compare to an 8 squared is 64? So then I have 16 plus 3 times 16 is going to give me 48. How does that compare to 64? And I get 64 is equal to 64, or this is again a right triangle. Okay, so two really tricky things there, where I have to know kind of what this number approximately is, and when I have a coefficient in front of my rad, I need to square both of those numbers. Okay, so on this page, there's 5 more of these. Only one has a radical. I'm going to let you, geometry students, kind of just start working through and figuring out which inequality do you have and what triangle do you think that is. Okay, so I'll give you like a minute or so, and then I'm going to start filling some of them in, and we'll kind of talk through what they are, okay, what your final answer should be. Either obtuse, acute, or right triangle.